On a clear night, you can raise your eyes and find a faint, slanted smear above the horizon. It is not weather, not a trick of moisture, not even a cloud that forgot to move. It is Andromeda, a postcard mailed 2.5 million years ago that has crossed a silent ocean to arrive in your eye. The postcard looks like an invitation. There is a neighbor. The road must be open. The ceiling looks high, and the dark between us looks like a space we can cross with enough patience and enough fire. Hold that pleasant picture for a moment. Then notice what our best instruments whisper when the exposure is long. The farther we look, the faster everything retreats. No thruster is pushing those galaxies away from us, and yet the gaps between us swell. At first it feels like a misunderstanding. Perhaps our yardsticks are bent, or our clocks are off. Then the same message appears written in different inks. A rainbow of light from remote suns is stretched into lazier colors. The rhythm of distant clocks seems to slow. The milestones by which we measure distance, the lamps we think are a standard brightness, all slide to places we did not expect to find them. We point with confidence, and the map edits itself. Here is the paradox we can hold without poetry. Nothing outruns light in the usual way. Yet the fabric we move through can grow so quickly that places cross a line where light will never catch them. No law is broken. No alarms are tripped. The universe plays by its rules and still steals destinations from us in a quiet, methodical way. What do you call a hallway whose floor slides backward faster than you can run? How do you draw a route on a map that stretches while your pencil is down? If speed is a promise, what happens when the stage under that promise drifts like a slow glacier? Look again at Andromeda, steady and small. Then let your gaze drift into the mottled darkness between the bright points. The darkness is not empty. It is crowded with stories that are moving out of reach. A deep exposure reveals a field of powdered light. Each speck is a city of stars and time. Some are already beyond a horizon that is not a wall, not a dome, but a boundary made of delay. Light that set off long ago is still on the way. Light launched now from beyond that boundary will never arrive. There is no anger in this arrangement, no malice, no force that means us harm. It is arithmetic, written at a scale that makes our talents feel suddenly particular. A ship on an ordinary sea fights the water around it. A ship on the cosmic sea fights the metric of the sea itself. That is the quiet cruelty. Engines that push through space can be perfect in every way and still lose to a shoreline that accelerates away. We put numbers to it, and they sound as gentle as a nursery rhyme. Farther means faster. Double the distance. Increase the retreat. Keep going. And somewhere out there, the retreat wins against any engine that moves only through the water, rather than with the water. The horizon is not a cliff where ships break. It is a moving threshold defined by time that has not happened yet. Think of it like this. You step onto a moving walkway that quietly accelerates with every meter. Overhead, ceiling lights blur into a slow river. You sprint. You spend energy. You lean so hard your calves burn. And the walkway increases speed faster than your stride increases ground. The walkway is not a character in your story. It does not notice you, yet it decides what can be reached. We built instruments to test whether this picture is a trick of our eyes, a fault in our lenses, a bias in our methods. When light from ancient explosions arrives, we measure how bright they ought to be and how bright they are. Then we turn those numbers into a history of expansion. The story repeats in a harder dialect when we map the spacing of galaxies and find a fossil pattern, a rhythm that froze when the universe was young. That rhythm tells us the runway is not just long, it is getting longer, and the rate at which it lengthens has itself grown. The room of the universe has swelling corners, and those corners are running away from one another more quickly now than they did long ago. What if you had the perfect drive and the perfect shielding? What if you solved the heat that engines spit out and the charged shards of space that peel paint from hulls? What if your fuel was the output of an industry that crushes stars and your ship could last longer than continents do? There would still be one detail that does not care about ambition. The frame in which you move drifts like a glacier with a mindless schedule. Run east on a thawing lake, and the cracks do not respect your training. Is speed a master key or a promise that melts in a hand that sweats too much? How many suns must you spend to buy one more decimal place of velocity? How long do you need to live just to make the trip to an address whose name has started to fade? There is a second paradox folded inside the grand one. The Milky Way is rich beyond taste, a city of hundreds of billions of stars with neighborhoods so varied the mind has to slow down to notice them. Yet its districts are separated by deserts that already demand heroism. The road out of the city is not only long, it might be a painting we cannot step into. Still, in the scale that matters to people, we are not small inside this city. A single spiral arm holds more worlds than we have questions ready to ask. Is freedom a distance you cross or a depth you create? If one city can feed 1,000,000 centuries of curiosity, what exactly are we missing by not becoming a commuter between towns? Stand with me at the edge of the visible sky. There is a horizon there that is hard to feel. It does not block light that has already left. It does not insult your effort. It is a promise broken by delay. Light launched today from beyond that limit will not make it to us no matter how patient we are. Light launched toward us long ago may still arrive, and each arriving photon is a last chance from a region that is finishing its conversation with us. Beyond that edge, the universe keeps writing in a key we cannot hear. It does not need our attention. We do not need its permission to decide what to do with the key we can hear. So the hook of our story is not despair, it is a calibration. What follows is an investigation into limits that shape dreams into work. When a limit refuses to move, it does not remove meaning. It carves meaning into a sharper relief. We will test the pretense that velocity alone is a master fix. We will step into the desert between systems and ask what the desert takes from a traveler besides time. We will count the debts of shortcuts and check whether any known economy can pay them. We will design machines that age in slow time and ask if biology and identity can keep pace with hardware. We will treat silence as data and the fading of the far view as a schedule, not a tragedy. We will try to make meaning narrower and stronger, not because the universe wants us to be humble, but because the evidence suggests we have a finite stage on which to write a complete story. Take a breath and listen to the beach at night. The surf looks steady when you arrive. Under a long exposure, the waterline moves between blinks. You place a marker in the sand and come back later. The line has shifted. It will keep shifting. You can build a lighthouse. You can map every rock. You can light the harbor so well that no ship wrecks by accident. None of that cancels the tide. It transforms what sailing means. A tide does not argue. It repeats itself with patience until the coastline learns how to live with it. We will not outshout the tide. We will learn to speak over it, to time our voices between waves, to send our boats where they return with something valuable before the tide takes their path away. In plain terms, we are not being pushed back by a wind. The air itself is becoming more of itself, and far from shore it becomes more faster than any boat can compensate. The rules of motion are intact. The budget of energy is honest. The accounting of time is strict. The combination conspires to place faraway galaxies outside practical reach forever under the model that fits the data we have. That word forever matters, not as a sentence, but as a design constraint that asks for a better kind of effort. Now listen to the small scale where your hands still matter. Inside our one city, there are bridges of gravity, reservoirs of gas, storms that cycle on centuries, and worlds that keep secrets in thick ice and dense air. A civilization that knows how to read a city this large will not run out of urgent work. It may run out of fantasies that require the rest of the archipelago to sign off on our plans. If freedom is the right to shape a neighborhood until it sings, then the loss of distant commutes is not a loss of meaning. It is a focus. It is a sharpening stone that turns dull questions into the tools of a craft. Does this arrangement frighten you? Or does it focus you? If you knew a boundary would tighten over cosmic time, what would you choose to measure first? Which archives would you build before the view fades? Which ruins would you prevent by building better households aboard ships and stations? Which routes inside our own city would you map now while the lights between spiral arms are clear? What happens to a species when it stops pretending it can be everywhere and instead learns to be excellent somewhere? We begin with the simplest remedy and the most seductive myth, the idea that faster solves almost everything. There is a thrill in that idea because it aligns with our experience. In a room, speed wins. On a road, speed closes distance with a satisfying regularity. But a galaxy is not a room, and the road between galaxies does not behave like a road. To test the myth honestly, we have to put numbers on speed, mass, energy, shielding, and heat. Then watch how the arithmetic changes character near light speed. The table of costs begins as a budget and ends as a story about civilizations spending entire suns to buy a few more nines after the decimal. If speed stumbles, perhaps we try to starve the desert, to scoop fuel from the thin medium between stars, to stretch a ship's lifetime until travel feels like living rather than waiting. That plan meets chemistry and patience. It meets the physics of almost nothing, where even atoms become rare enough to change the rules. Then come the shortcuts that seem to fold geometry, the doors that appear in notebooks, the tunnels that excite our appetite for escape. Those doors have tolls, and their toll is payable in a currency that we have not yet found. If the bill cannot be paid, maybe coordination becomes our last clever move, a culture that tolerates silence as the price of scale. But if messages take centuries, coordination becomes inheritance, and a conversation becomes a museum exhibit. There is still a gift inside the limits. The gift is a task. We can map, then preserve. A complete history of one galaxy before the distant view fogs for good. We can plant lighthouses that outlast our impatience. We can define excellence as completeness rather than reach, as depth rather than speed. A finite stage is not a punishment. A frame lets a painting exist. The frame does not diminish the canvas. It allows the image to hold. Enjoy evidence-first space films. Like and subscribe to the Quiet Universe channel. If speed fails our ambition, we step into Chapter 1 and test the invisible walls that space itself raises. Stand on a pier at night and study the harbor. The breakwater is invisible from where you stand, but you can hear its authority in how the waves fold and turn. The sea moves, yet the ships obey lines you cannot see. Now lift your view from the pier to the sky and imagine the entire Milky Way as that harbor. The invisible structures are not stones. They are rules written into the fabric of distance and time. They do not bruise the hull. They do not leave marks on paint. Yet they decide where travel ends. Call them walls you cannot touch. The first clue is plain, almost impolite in its directness. When we spread the light of distant galaxies into stripes, the dark lines that belong to specific atoms have slid toward red. That shift is not the boat moving past the buoy. It is the buoy itself drifting as the water swells. The farther the galaxy sits from our pier, the greater the slide. We can map the shift against distance, and the pattern lands with a thud of consistency. Farther means faster retreat. Past a certain distance, the retreat outpaces the speed any signal can make through space. What do you name a barrier that is not placed in your path but grows beneath your feet? If the horizon retreats faster than you can chase it, what is a journey? We test the honesty of the light with more than one trick. We measure standard beacons whose wattage we can infer from their behavior. We compare how bright they appear to how bright they should be. And the ledger repeats the same correction. The rooms between galaxies are stretching. The rate of stretching is not constant. On very large scales and late times, the stretching accelerates. You could build engines that nearly lick the speed of light, and still the shoreline, that subtle curve where space itself carries one region away from another, will win without raising its voice. At its core, a galaxy far enough away does not flee through space. Space increases between you and it, so your speed through space becomes irrelevant beyond a moving limit. This is not a matter of engines or skill. It is geometry with a clock attached. You cannot cut a straight path through the harbor when the water carries the pier and your boat in opposite directions without caring which one you wanted to approach. The second clue hides in time. Signals that left early in the life of the universe arrive faint and tired. They also arrive slower, stretched by the same swelling that reddens their color. Play a distant event as a movie, and the frames take longer to arrive than they would if the floor beneath all actors were still. Time itself, as experienced between far shores, does not line up. If clocks cannot agree, how do you schedule an arrival? If the very measure of duration changes with separation, what does an itinerary even mean? We can pretend to ignore this and plan a voyage with heroic optimism. Take a notional craft that can sustain continuous acceleration, shield its crew from radiation, and dump heat in the most efficient way known. You still must ask what the harbor allows. There is a radius beyond which your plan becomes a diagram without a pier to moor at. The target has slid outside the class of reachable places as judged by signals launched now. It is a wall made of delay, not of stone. Does refusing to name the wall change what it does? The third clue is how these walls change the map with time. In the deep past, more of the ocean lay within possible reach given patience. In the far future, fewer shores will exchange light. The harbor narrows. Routes do not close with a bang. They fade until your best charts look like a palimpsest of discarded roads. This matters because exploration is not only a question of bravery or fuel, it is a race with a boundary that drifts. Each year, the list of addresses that can ever reply grows shorter by a hair that no sailor can feel, but every ledger can count. Why wait for doors to become windows, then mirrors? Why let the record of what once was near slip into a class of things that can only be guessed? Simply put, there is a difference between a long voyage and a forbidden one, and some destinations are promoted from long to forbidden by the slow arithmetic of expansion. You can plan for long, you cannot plan for forbidden. The fourth clue arrives from the structure in the sky itself. If we scatter pebbles into a pond, they leave rings that spread outward. Long ago, the young universe rang with waves in its thin fire, and those waves left a fingerprint in the way galaxies prefer certain separations. We can measure that spacing and use it as a yardstick that does not care which way we face. The yardstick has the same story written into it. The scale of separation grew as space grew, and its present value tells us how the growth changed tempo. The harbor is not still. The walls move, and their motion has a history. Why this matters should be said without ceremony. A barrier that cannot be negotiated forces us to redirect genius. Skills that were once aimed at intergalactic reaching must be poured into finer maps of what we can still touch. If the far view will fog, we must capture it now. If the ledger of reachable places will shrink, we must decide what sciences and archives to advance while the window remains open. A wall without surface still exerts pressure. You feel it when you calculate fuel for a mission beyond any known return. You feel it when you treat radiation not as a nuisance, but as weather that grinds machines and cells. You feel it when you design life support that must work for times longer than languages tend to remain the same. Those are hard problems that deserve our best hours. But the wall we speak of stands before those problems even start. It tells you which problems can ever lead to a handshake at the other end. Here is where doubt usually enters with good manners. Perhaps the measurements are bent by things we have not understood. Perhaps dust changes the light. Perhaps we selected the wrong beacons. The remedy for that kind of doubt is redundancy. The sky has offered more than one way to count. Different devices, different populations, different fossils of early behavior, all converge on the same counsel. The counsel is not cruel. It is indifferent. And indifference is what reality does when we finally ask a well-posed question. What kind of wall is indifferent? It is the kind that belongs to a rule rather than an object. A pier you can ram. A rule you can only respect or bleed patience against. If our harbor had rocks, we could dynamite a channel through them. If our harbor is the motion of the water itself, our choices look different. We might enlist currents that already flow. We might become navigators who time departures to the quiet moments between swells. Or we might accept that some exits are illusions painted on fog, beautiful to picture, deadly to chase. The visual world helps. Picture a field photographed for weeks, a square of sky so small you could hide it behind your thumbnail. The image fills with faint grains of light. There are more cities of stars in that square than there are people you will ever meet. It is intoxicating to imagine sailing from grain to grain. The photograph carries a second message in its hush. Many specks sit beyond the line where even light sent now will not make it to us. The picture is not an invitation. It is a record of old exchanges nearing their end. What should a thoughtful species do about walls it cannot touch? The answer is neither despair nor denial. The answer is to turn a constraint into a scaffold. Design exploration around the rule. Design archives around the fog. Scout the local group with a seriousness that matches the scale of the city we actually inhabit. When a wall is abstract, the tools look concrete. Better detectors, better timing, better propulsion for the places that remain within physics, not hope. Better life support for voyages measured in centuries within a single spiral arm. Better treaties between laboratories so that knowledge survives the drift of budgets and eras. Here is the human scale that matters. You do not need to touch another galaxy to fill a lifetime, or 1,000 lifetimes, with honest discovery. Our harbor contains stellar nurseries that remake the night. It holds black hole neighborhoods that feed and sleep in cycles that can be watched. It contains worlds where chemistry plays patient games in seas of rock and air. The wall does not remove meaning. It imposes a curriculum. What about clever workarounds? The ones that try to use the harbor's motion rather than fight it. If the water swells, can you surf the swell? If gravity curves space, can you drop into a slope and climb out beyond the line where light loses? These questions are worth asking because they might reveal a loophole that the rule did not forbid. But every attempt so far trades one price for another. Timing the swell requires you to be in the right place with the right energy at the right epoch. The swell itself changes speed with distance. The currents that look helpful near shore turn into rips that carry you away from every beacon you wanted to reach. What this means is that the most honest chart begins with the wall, then draws everything else inside it. Only then do we spend attention on the fine art of edging closer to the line without pretending the line is imaginary. A chart like that is not smaller. It is truer. And truth scales your tools to the problem, so your tools do not break when you need them. Why it matters returns in a different tone. A civilization that knows the true size of its harbor plans institutions to fit. Education focuses on patient skills. Industry stabilizes the long projects that pay off in decades and centuries. Archives are treated like lighthouses, not basements. Law learns to protect experiments that run longer than elections. The wall teaches culture as much as it teaches physics. We should ask the hard questions out loud. If a galaxy becomes unreachable in principle after a certain time, is there any point in trying to leave a message for it? If the answer is no, should we redirect that effort into making messages that last within the harbor we can actually patrol? If the answer is yes, what form does a message take when it cannot ever be read by the intended eyes? When you pose these questions honestly, they stop being romantic and become ethical. They are questions about how to spend finite attention in a place that will reward diligence with real-world, permanent gains. The motif for this chapter has a name that fits the feeling at the pier. The veil of light is what you live behind when every distant lantern you love sends its beam through a medium that stretches it thin. A veil is not a wall. You can see across it, sometimes beautifully, but if you try to step through it, you discover it is not cloth you can lift. It is the behavior of the brightness itself. The veil thickens with distance until intention dissolves. You do not cut a veil like that. You learn to photograph it well and to preserve those photographs before the dyes fade. There is a last, quiet detail that surprises almost everyone the first time they meet it. The harbor may keep us, but it keeps us together. Gravity holds the Milky Way, and its near companions in a bound dance even as the rest of the city lights drift away. Our walls are broad and patient, yet within them, there is space enough to work for ages. If you crave a challenge large enough to respect your species, the local group obliges. The invisible breakwaters that protect a harbor can feel like a cage to someone who wants only open ocean. To a builder, they feel like a guarantee that the docks you raise will not wash away next season. Why it matters is now simple to say. If we misread the wall, we misallocate centuries. If we read it correctly, we can complete a history of one galaxy, not as consolation, but as a masterpiece that would otherwise be impossible. We can aim the best minds at problems that match the scale of what remains reachable. We can turn away from performances that pretend to erase the wall and turn toward performances that make the harbor flourish. So we name the barrier without ceremony. We test its edges with honest devices, and we plan our work inside it as if our descendants will judge us on whether we filled the harbor with light instead of shipping nonsense into fog. What better use of bravery than to meet a real boundary and make a great city inside it? To move from walls to engines, we must ask whether speed itself is a solution or a mirage that eats fuel faster than it returns distance. Every engineer knows the appeal of the number 300,000. It glows with the precision of a frontier. 300,000 kilometers each second. The ultimate ticket through space. The cosmic speed limit printed on every photon. For generations. We have treated that number like a wall to break, or at least to scratch with our fingernails. The story of engines is the story of acceleration. And the story of acceleration ends in a mirror that stares back with arithmetic instead of sympathy. The faster you chase light, the heavier you become, the hungrier your machine grows, and the fuel you carry begins to fight the very purpose it was meant to serve. The clue that opened this chapter came from clocks and twins. One stays home, one travels fast. When they meet again, their stories of time disagree. It is not imagination, not equipment drift. It has been tested by atomic clocks flown on jets and by particles that live longer in motion than when at rest. Motion stretches time and reshapes mass. As speed climbs, energy does not rise politely. It climbs a wall that curves toward infinity. No budget can buy infinity. That is the quiet victory of the limit it wins without ever moving. Why do we imagine it is waiting to be conquered, when its nature is to remain where it is and let our costs pile up beneath it? Suppose a ship wants to travel a respectable fraction of light speed, say 10%. Already, each kilogram of mass demands a budget equal to months of sunlight. Increase the goal to 99%, and the cost explodes. Shielding, coolant, structure, everything counts as mass. And mass demands more fuel, which in turn adds more mass. It is a trap that tightens each time you try to escape. The rocket equation is an honest broker. It tells you that to reach a high velocity and stop again, the fuel you need must be exponential, not generous. Exponential is another word for impossible when patience is measured in centuries. Think of it like this: you try to drive uphill, and the hill itself grows taller as your engine roars. Every gain in speed steepens the slope. Every burst of thrust adds weight to your vehicle. The hill is not punishing you. It is geometry with manners. It responds to your intent by raising the cost. That is how the universe teaches thrift. The clue deepens when we remember that energy has no free compartments. The faster you go, the more energy converts into radiation. Collisions with dust, even a grain the size of sand, become explosions at near light speed. The vacuum is not empty enough to forgive that. Cosmic rays, magnetic fields, scattered atoms, each one becomes a bullet when you rush toward them. Shielding that can survive the journey must be thick enough to stop those impacts, which means it adds more mass, which demands still more fuel. Speed consumes the future it was supposed to deliver. You can try to solve the problem with elegance instead of brute strength. Ion drives whisper rather than shout, trading thrust for endurance. They sip their propellant, pushing gently for years. Their exhaust travels faster than bullets, yet the total push is small. They work for interplanetary travel, not interstellar ambition. For ships that want to cross from star to star, patience is not enough. The mathematics of inertia insist that the bill grows faster than the distance shrinks. At its core, the relativistic equation that defines kinetic energy has a curve that bends steeply. Add speed, and the energy rises not as a straight line, but as a cliff near the limit. The curve goes almost vertical. You are no longer buying velocity. You are buying mass that insists on being heavier the more money you spend. No accountant can balance that ledger. What this means is that the universe protects its fabric by making recklessness unaffordable. You can dream, you can design, but you cannot hide the cost in another column. The arithmetic will find you. The second clue appears in the small, fierce world of particles. We accelerate protons to near light speed and watch them collide. The machines that do this are vast rings that gulp entire city grids of power. The particles weigh almost nothing, yet the energy required to add another 9 after the decimal grows like a mountain. We know the pattern because we built it ourselves. The curve is not a metaphor. It is a bill written in megawatts. When we build ships instead of atoms, the same law applies, and the scale becomes comic. To move a craft, the mass of a building near light speed would need energy rivaling the yearly output of a star. In plain terms, faster travel is not blocked by magic. It is blocked by bookkeeping. Energy has weight, and weight fights acceleration. Each solution feeds its own opponent. The elegant lines of a starship sketch hide that circular argument inside their beauty. When fuel is energy and energy is mass, your fuel tank becomes your cage. Even if you had the energy, you must consider the heat. Engines that transform colossal power into motion generate waste that must be rejected somewhere. In space, there is no air to carry heat away. You radiate it as light, which means you need panels to glow it out. Panels add mass. Mass slows you down, and the loop begins again. A real interstellar ship would shine like a furnace long before it reached any meaningful fraction of light speed. Visible not as a dart, but as a slow ember dragging its problem behind it. Why this matters reaches beyond engineering. It sets the rhythm of every possible migration. If moving faster eats your ship, your culture must live slower. Time dilation. The strange grace that makes travelers age less than those who wait becomes both a gift and a poison. A century aboard might equal 1,000 years at home. The travelers return as strangers to a world that forgot them. They gain time personally while losing time collectively. A civilization that moves at near light speed tears itself across its own history. We can soften the blow with speculation. What if we move minds instead of matter? Signals instead of ships? Information travels at light speed without weight, but information still obeys the same frontier. You can send a message, but you cannot send it faster than light. The limit laughs at both ambition and cleverness. It is impartial. You can mimic the universe with math, yet math itself lives under the same ceiling. The treadmill image fits here. Imagine running on a track that accelerates as you sprint. The floor beneath you responds to your effort by speeding up its own pace. Your muscles burn. The distance on the clock climbs, but the scenery barely moves. You can shout encouragement to yourself, but the treadmill listens to a deeper rule. It cannot be persuaded. The faster you chase, the hungrier it becomes. That is the cosmic treadmill. You do not step off it. You design your life around not being consumed by it. Why it matters is not despair, it is discipline. Knowing that speed demands everything pushes us to redesign what progress means. Instead of faster, we might aim for smarter, lighter, more continuous. We could seed the journey with autonomous machines that build waypoints long before humans follow. We could focus on preservation rather than conquest, on the richness of one harbor instead of the fantasy of endless departure. Still, the instinct to push remains noble. Every test of velocity teaches us another corner of the same truth. When astronauts circle Earth, their clocks tick a little slower. When satellites orbit, we correct their timing to match ours. The cosmos enforces its consistency at every scale. The difference is small in our daily lives, vast in cosmic terms. Precision navigation depends on acknowledging this quiet difference, on folding relativity into the work rather than pretending it is an inconvenience. The wall of speed is not a punishment. It is a requirement that forces precision to become a virtue. There are further consequences. Radiation grows with velocity, making the empty path between stars an ocean of knives. Every cosmic ray that glances harmlessly off a stationary hull becomes a chain reaction at high speed. Even shielding a few centimeters thick becomes an engine of secondary radiation as particles crash and split. To move fast is to turn the universe into a storm that you must continuously endure. That price, added to the energy debt, defines the true difficulty of leaving the cradle. So, if speed becomes its own enemy, maybe the future of travel is not to chase light but to bend time. That thought invites a different class of hope, one that speaks in curvature rather than thrust. The wall at the top of this hill does not end the story. It redirects it. Every civilization that reaches this understanding faces a choice. Keep climbing the same hill, or learn to rewrite the map. The first choice builds better rockets. The second imagines roads that fold space or cheat its distance. Both require faith. But only one admits that the fuel bill cannot be paid forever. If we accept the speed limit as a law rather than a dare, we can still ask how to use its side effects. Time dilation, once a nuisance, becomes a method. A journey that seems endless from outside can be compressed for those inside. That is how relativity softens its own blow. By giving travelers subjective reprieve while preserving the cosmic order, the universe bends without breaking. The limit holds but leaves room for poetry. So we begin to see speed not as freedom but as a teacher. It tells us what energy means, what patience costs, and how closely desire and exhaustion are related. A speed limit that eats your fuel is not only physics, it is a mirror for civilizations that forget to budget their enthusiasm. The metaphor that fits this chapter is the treadmill that accelerates as you sprint. You cannot win by running harder. You win by understanding why the treadmill exists at all. It keeps the universe coherent. It protects the timeline that binds cause to effect. It ensures that messages have context and events have sequence. Without it, even meaning would evaporate. Why it matters finally becomes personal. Every era discovers its own version of the same wall. We have found ours in the mathematics of velocity. The next generations will find it in energy budgets, radiation limits, and the sociology of long missions. The limit is not an obstacle to exploration. It is the rule that ensures exploration remains real. It keeps us from pretending we already know the answers. It gives us time to build the tools to ask better questions. If the cost of speed devours its reward, perhaps the answer hides in the spaces between. The next chapter will enter that emptiness, the desert between galaxies, and ask what survives when even fuel has nothing left to burn. Imagine stepping out from the edge of a city into a wasteland where even air becomes a memory. That is what lies beyond the edge of the Milky Way. We call it intergalactic space. But the word space sounds too neat, too orderly. It suggests a room you can measure, a vacuum you can cross. What stretches between galaxies is not a room, but a gulf. It is the nearest thing to nothing that physics can find, yet not truly empty. A few atoms drift in every cubic meter, ghosts of hydrogen left from an age when everything was hotter and closer together. That sounds generous until you do the math. 1 atom per cubic meter means that if you tried to scoop a cupful, you would wait centuries for it to fill. This is the desert between galaxies, a place with no horizon, no shade, no rest stop, and no reliable source of anything. Light travels for millions of years through this gulf and barely encounters a single atom. A ship would move for generations and never smell a whiff of oxygen, never find a particle thick enough to call dust. The silence here is not just the absence of sound. It is the absence of interactions. Even radiation is thin, diluted until it becomes more a rumor than a force. The first clue that tells us this desert exists came from counting what we could not see. When we mapped galaxies, we noticed they form webs and filaments, leaving vast cavities between them. Those cavities are not filled with invisible stars or planets hiding from our telescopes. They are voids, spanning hundreds of millions of light years, regions where matter never gathered enough to ignite. The structure of the universe resembles foam, the galaxies as the bright walls, and the voids as the bubbles between. To cross one is to travel through the thin skin of creation itself, a stretch of time so uneventful that the concept of direction becomes abstract. Think of it like this. The universe has oceans and continents, but also deserts where the wind never blows, and the dunes are made of light years. The voids are those deserts. A ship moving through them would be like a caravan without a compass, pulling its entire water supply across a distance that mocks endurance. A second clue comes from the faint whisper of the intergalactic medium. Instruments that catch ultraviolet light and X-rays find traces of highly ionized gas, sparse enough that each cubic kilometer contains less than a gram of matter. It is there, but only barely. When photons from distant quasars pass through it, they lose a fraction of their energy, leaving fingerprints in the spectrum we observe. The pattern reveals a scattered fog of material, heated by ancient collisions, but so thin that calling it matter is an act of generosity. Why does this emptiness matter? Because fuel, friction, and radiation are the vocabulary of travel. In the desert between galaxies, all three vanish. You cannot refuel, because there is nothing to scoop. You cannot slow down, because there is no drag. You cannot cool easily, because there are no molecules to carry heat away. A ship there would need to take everything with it: air, water, fuel, memory, and carry the responsibility for its own temperature. The journey becomes not a path, but a sentence you must live with the same supplies you launched with, perhaps forever. At its core, intergalactic space is a graveyard of possibility. Particles float with so much distance between them that they almost forget each other exist. Magnetic fields wander without tether. Even gravity is diffused, pulling in no clear direction until a traveler gets close to another galaxy's domain. If speed was the first enemy of explorers, emptiness is the second. It kills not with violence but with patience. It does not oppose you. It erases the context that makes motion meaningful. The third clue hides in the light that tries to cross this emptiness. Starlight fades not only with distance but with redshift. The farther it travels, the more stretched it becomes, losing energy as the universe expands underneath it. What reaches the other side is not the same light that left its source. It is older, colder, gentler, a ghost of illumination. For a ship's sensors, that means the view dims until there is nothing to navigate by. The desert does not even offer a horizon to steer toward. Every direction looks like every other. In everyday language, the road between galaxies is not paved. It is unmade, where we might expect more of the same, more stars, more dust, more gravity. We find less of everything, until the concepts themselves begin to fade. This is what empty truly means, a state where the rules of persistence wear thin, and everything that lives must carry its own reference frame to remember what it means to be alive. To cross such a desert, you must rethink what travel is. The idea of constant acceleration loses meaning when there is no halfway point to aim for. The notion of a destination loses meaning when light takes tens of millions of years to mark your progress. You do not cross a void, you inhabit it, and even that is generous. You drift, wrapped in a cocoon of stored air and stored hope, while the background radiation cools around you like an endless night. The metaphor that fits is a desert with one atom in a room. Imagine standing in a cathedral so vast that a single grain of sand floats miles from the next. That grain could drift for centuries without colliding with another. The scale mocks the traveler. The vacuum becomes both space and wall. simultaneously allowing motion and forbidding contact. It is freedom stripped of its warmth. Scientists once proposed clever ways to drink from this vacuum. One idea is the Bussard ramjet, a ship with an enormous magnetic scoop that gathers interstellar hydrogen to feed a fusion engine. But in the desert between galaxies, even that dream dies. The density is too low. The drag from the scoop would exceed the thrust it provides. The concept becomes like trying to drink from a river that is no longer there. The math ends with negative acceleration, a poetic way of saying the faster you try to go, the quicker you stop. Why it matters is clear. Even imagination has borders set by physics. The desert demands not larger engines, but different thinking. Instead of racing across, we might need to send messages, probes, or spores of information that require no return. The distance becomes not a highway, but a one-way whisper. Some speculate that civilizations reaching this boundary might choose to slow themselves, to enter deep time instead of deep space. If your voyage takes millions of years, perhaps you sleep, or transform into something that can wait. Maybe your species evolves into code, dispersed as quantum echoes stored in self-healing machinery, drifting like pollen through the void. Even then, the desert dictates the rhythm. Communication decays. Updates fail to arrive. The scattered seeds become separate stories. What this means is that the dream of intergalactic travel may survive not as movement, but as correspondence. Perhaps the great ambition of advanced life is not to go elsewhere, but to send artifacts ahead, a wave of machines that will outlive even the decay of their makers. Yet, the desert is long enough to devour even that hope. Over the course of cosmic time, expansion will carry the galaxies so far apart that light from one can never reach another. Messages will be written but never delivered. That is the final silence of the desert. Not noise, not darkness, but disconnection. In plain terms, the desert between galaxies is a perfect teacher of patience. It reminds us that survival is not about conquest. It is about managing solitude. Every species that looks outward must decide how to thrive when outward offers no comfort. The answer may be to treat each galaxy as a self-contained garden, to turn curiosity inward without turning hope off. On a human scale, this principle already applies. The farther we send our probes, the quieter they become. Voyager still speaks, but faintly, its messages arriving with the weight of years. Each packet of data is a memory traveling through growing silence. The pattern repeats at larger scales. A galaxy's last transmission to its neighbor will one day take longer than the universe's remaining life to arrive. The letter will outlive the mailbox. Why it matters comes down to stewardship. If we cannot reach others, then what we preserve within our own spiral becomes the only legacy we can guarantee. The desert teaches restraint. It teaches care. It asks whether meaning requires an audience or whether the act of creating and maintaining life is its own form of communication. Some dreamers still imagine ways to fight the desert. They talk about cosmic strings, wormholes, or negative energy corridors that could fold distance into something local. These ideas belong more to equations than engines, but they serve a purpose. They remind us that curiosity itself is the oldest form of propulsion. To calculate, to test, to disprove, those are acts of travel inside the mind, the one realm where distance does not dictate worth. The desert does not mock us. It defines us. The silence between galaxies is the backdrop against which the rare noise of life becomes meaningful. In that context, every radio pulse we send, every telescope we build, every story we tell becomes an act of defiance against nothingness. Still, defiance is not denial. The facts remain between galaxies lies a void that no ship can cross in a single story. The challenge of that void does not shrink us. It forces us to imagine civilizations that work on timescales longer than continents last, that plan for epochs rather than years. Those who can think that far ahead will become gardeners of the possible, patient with the pace of stars. A caravan cannot hate the desert it crosses. It must learn its rhythm. It must carry its own water and its own light. So will we. If we ever sail beyond the Milky Way, our lanterns will be memory. Our maps will be songs of where we came from, and our silence will be a kind of prayer that distance cannot erase. If the desert cannot be conquered, perhaps it can be endured. That is the theme waiting on the horizon when machines inherit the duty of persistence. Can they outlast entropy itself? Inside every engine, clock, and heart lies the same sentence: nothing stays ordered forever. The more carefully we arrange things, the more the universe insists on unwinding them. This rule, called entropy, is not a curse invented by pessimists. It is the quiet bookkeeper of energy. Everything useful, everything structured, slowly dissolves into less useful forms. To live, to build, to travel. We borrow order from our surroundings and pay it back later as waste heat and disorder. Against that slow undoing, we build machines, hoping that cleverness can stretch the interval between spark and silence. Our first clue comes from the limits of closed systems. A spaceship, no matter how advanced, is a miniature ecosystem. It breathes, recycles, and radiates. It must shed waste heat into a vacuum that offers no comfort. Its walls keep matter inside but not entropy outside. As engines hum, the heat they release must go somewhere. Radiators glow like dull red wings, bleeding energy into space. If they fail, the ship cooks itself from within. A vessel crossing interstellar distances carries not only its crew and cargo, but also a growing burden of statistical debt. Every process that maintains life consumes gradients of order, gradients that must be rebuilt faster than they decay. In plain terms, a closed world cannot remain perfect for long. Its air filters clog, its lubricants thicken, its circuits age in ways no software patch can undo. Even if we conquer propulsion, this quiet unraveling waits. When we imagine long voyages, we must imagine how to slow this decay without deluding ourselves into believing we can stop it. To test the idea, we have already built prototypes on Earth. The International Space Station and Biosphere 2 are microcosms of hope and warning. They show that maintaining balance in a sealed environment is an art that never ends. Oxygen must be regenerated, carbon dioxide scrubbed, water recycled until it becomes nearly eternal. Yet even there, with constant care, systems drift. Chemistry sneaks in subtle surprises, materials outgas, sensors fail in silence. What survives is not perfection, but resilience, the capacity to repair faster than decay. The second clue lies in our machines themselves. Every self-repairing mechanism we invent eventually confronts the question of recursion. Who repairs the repairer on Earth? We rely on evolution and redundancy. Cells divide, DNA copies, errors are corrected by more errors until balance emerges. In space, that process must be engineered. Imagine nanobots crawling across the hull, patching microfractures before radiation makes them bloom. Imagine swarms of autonomous drones tending solar sails or shielding systems. Each of these solutions adds complexity, and complexity is another word for new ways to fail. Entropy hides inside cleverness. At its core, the struggle against entropy is the struggle to maintain gradients. Life feeds on difference, hot and cold, high and low, ordered and disordered. When difference disappears, so does function. A ship powered by fusion must handle its own miniature sun while keeping the cabin livable. Waste heat pours outward through radiators the size of continents. Even a perfect design would eventually erode as atoms migrate through metals, as radiation blisters electronics, as cosmic dust sands away the polish of ambition. Think of it like this: a watchmaker builds a perfect clock, seals it, and sets it in motion. Over time, dust infiltrates, lubricants dry, gears misalign, the clock slows, then stops. Now replace dust with cosmic rays, replace gears with civilizations, replace seconds with millennia. The pattern does not change. The clock becomes the universe's quiet reminder that endurance is an illusion we maintain through effort. Yet humans persist in trying. We imagine biomechanical hybrids, ships that are gardens as much as engines, algae scrub carbon, bacteria recycle nitrogen, fungi digest waste. Such designs mimic Earth's ecosystems, outsourcing maintenance to life itself. The dream is not immortality, but sustainability, turning the slow grind of entropy into a rhythm that can be danced with instead of fought. We call this closed-loop life support, but in practice it is an orchestra that needs constant tuning. Why it matters reaches beyond technology. The fight against entropy defines what civilization means. To build is to resist decay. To remember is to resist forgetting. Each archive, each city, each work of art is a local victory against the universal drift. Our machines are extensions of that instinct. They let us postpone the inevitable, and in postponement, create beauty. In the deep future, when galaxies drift apart and stars age into embers, even machines may try to inherit that duty. Imagine self-replicating probes scattering through the cosmos, gathering resources, building copies of themselves to continue the lineage. These von Neumann probes could fill the Milky Way in a few million years. But they too will age, mutate, and decay. Without oversight, they might turn from gardeners into weeds, their purpose warped by time. Entropy does not just break things, it confuses meaning. Even code corrodes. Simply put, every long-term machine must solve not only physics but philosophy. How do you encode a purpose that survives erosion of memory? How do you make meaning durable when even stars are temporary? A probe that forgets its mission becomes a rock with ambition burned off. A civilization that forgets why it fights decay will let entropy win by neglect rather than force. The metaphor for this chapter is a clockwork garden rusting in slow motion. Its pathways are lined with silver gears and living moss. Sunlight glints off 1,000 moving parts. Yet somewhere beneath the rhythm, metal oxidizes. Circuits corrode. Roots creep into the seams. From afar, it looks eternal. Up close, it is perpetually dying and being reborn. That is what survival looks like on the cosmic scale, maintenance disguised as grace. A fourth clue hides in the data we already possess. Spacecraft that have outlived their intended missions, like Voyager, are monuments to defiance. Each year their power weakens. Their systems shut down one by one, yet they continue to send whispers across the dark. Their batteries decay, but their messages persist. They are machines against entropy, their songs growing fainter, yet more profound. They remind us that duration itself can be a form of victory. In everyday language, entropy is the universe's way of mixing everything together. Cold meets hot, structured meets random, and soon there is no difference left to exploit. Life, thought, and technology are local protests against that blending. We delay the average. We carve out temporary oases of order and call them civilizations. The fact that they end does not mean they fail. It means they participated honestly in the grand exchange. The fifth clue is our understanding of computation itself. Information has physical weight. To erase a bit of data releases heat. The more complex a mind becomes, the more carefully it must manage its thermodynamic costs. A thinking machine that wants to last must be frugal with memory. Perhaps the future will belong to quiet minds, slower processors that trade speed for longevity. The loud, hot intelligence that burns like a star will fade first. The whispering archivists that sip energy will last to see the universe cool. Why this matters becomes personal again. On a planet warmed by a nearby star, entropy feels slow enough to ignore. In deep space, it becomes a companion you must negotiate with daily. Every breath, every photon, every calculation has a cost. Learning to balance that budget is what turns survival into art. The real question is not how long machines can last, but how long meaning can. Some philosophers suggest that civilizations capable of enduring entropy might move inward rather than outward, compressing experience, optimizing memory, slowing subjective time until the universe seems eternal. That path is introspection made literal, a culture folding into thought to minimize waste. In such a future, the galaxy might fill with silent minds thinking at glacial speed, preserving information in the smallest possible changes of state. The heat death would still come, but more slowly. And in that slowness, consciousness might stretch far enough to witness it. We return, then, to the image of the garden. Each leaf, each gear, each breath of machinery plays a note in a melody written against noise. The goal is not to win, but to keep playing. Entropy is the beat. Life and technology are improvisations over it. The music ends eventually, but what a concert it can be. If our ships and cities can internalize that lesson, repair as rhythm, maintenance as culture, then perhaps the act of resisting entropy will become indistinguishable from the act of living. Machines will not fight decay. They will grow through it. Civilization will not seek immortality. It will seek continuity. And meaning will become the art of maintaining what matters as long as possible. Entropy will have the last word, but we choose the language it speaks. We can fill that language with order, with compassion, with purpose. We can teach our machines not just to endure, but to remember why endurance matters. When engines and ecosystems tire, when the glow of radiators dims and circuits hum their last songs, the next question becomes inevitable if maintenance fails. Can geometry itself provide a shortcut? Every civilization that grows restless eventually looks for a loophole in the laws that cage it. If speed fails and endurance only buys time, perhaps the answer is not to move faster, but to make the road itself fold. That idea has haunted physics since we first realized space and time are the same fabric. If they can stretch, they might also bend, twist, or tunnel. The dream is seductive, a shortcut through geometry, a wormhole to somewhere unreachable. The reality is colder. The price tag for such shortcuts may be written in currencies we do not possess. The first clue that such paths might exist comes from Einstein's equations themselves. They permit space-time to curve in ways that connect distant regions. Mathematically, there is nothing preventing 2 points from being closer in the geometry of space-time than they appear in ordinary distance. In the 1930s, the idea of a bridge between regions, what we now call a wormhole, was born from those equations. It is a tunnel through the metric itself, a tube connecting two mouths. Walk through one mouth and you could, in principle, step out in another galaxy or another epoch. Yet mathematics is generous. It allows ideas that the universe refuses to build cheaply. The second clue is the toll these bridges demand. To stay open, a wormhole would need to resist collapse. Gravity pulls its throat shut at the speed of light, and ordinary matter cannot fight that. The only known substance that could push back is negative energy, a form of stress that behaves opposite to everything we know. It does not weigh, it repels. Small amounts of it have been glimpsed in quantum experiments like the Casimir effect, but the quantities required for a usable tunnel are astronomical. To open a doorway wide enough for a ship, you would need more negative energy than all the stars in a cluster emit in a lifetime. A toll paid in currency the universe does not mint. Simply put, shortcuts are real in math and fictional in practice. The universe teases us with diagrams, then charges impossible fees at the gate. Each proposed design warp drives, Einstein-Rosen bridges, Alcubierre bubbles shifts the cost from distance to energy, from space to curvature. The road does not disappear. It hides in the interest rate. Think of it like this. You find a toll road that promises to cut a day's travel into a minute, but the toll collector demands more than all the wealth you will ever earn. You can see the archway shimmering, but the currency in your pocket evaporates when you approach. The road was never meant for travelers. It was meant for thought experiments. Yet we keep asking, could nature herself have already built these bridges? Black holes, those regions where gravity bends light into submission, seem like possible doorways. Their equations echo the mathematics of wormholes, but the insides of black holes are one-way tickets. Crossing their horizon is not travel, it is surrender. The tunnel pinches off long before an exit forms. The shortcut collapses before you arrive. That is the paradox that gives this chapter its name. At its core, every attempt to beat distance through geometry faces the same adversary energy density. Bending space-time requires mass, and mass curves space toward itself. To open rather than close a throat, you need the opposite kind of curve. The required stress is negative in both direction and intuition. So far, the only examples nature offers are microscopic and fleeting quantum ripples between metal plates or the delicate balance of virtual particles. Nothing large, nothing stable. It is as though the fabric permits threads of magic but forbids tapestries. The third clue lies in time itself. If a wormhole could exist and remain open, it would not merely connect space. It would connect moments. Move one mouth, and you have built a time machine. Step through, and you could meet your own history. The paradoxes this spawns are not literary. They are logical. To prevent causal loops that violate consistency, the universe may censor such configurations before they grow. Some physicists call this the chronology protection conjecture, the idea that time protects itself by closing shortcuts as soon as they form. The door slams in your face, but gently enough that you never notice it was real. Why it matters is simple and merciless. The geometry of the cosmos rewards patience, not cheating. If the laws forbid cheap travel, they also guarantee stability. Stars form, shine, and die in predictable cycles. Signals propagate in order. The price of reliability is confinement, freedom. In this framework means knowing your boundaries and building wisely within them. The fourth clue we must consider is the occasional loophole that tempts otherwise rational minds. The concept of warp drives pockets of space-time that move faster than light relative to distant observers resurfaces every few years. The math allows them under specific conditions. A bubble of space expands behind the ship and contracts in front, carrying it like a surfer on a moving wave. Locally, nothing breaks the light barrier. Globally, the ship crosses vast distances quickly. The cost, again, is negative energy. Worse, the front of the bubble cannot be controlled from inside it. The traveler can neither steer nor stop until the bubble collapses, a shortcut that closes when you arrive, sometimes before. At this point, the pattern becomes clear. Each proposed escape replaces one impossibility with another. Need more speed. Pay with infinite energy. Want to bend space, pay with exotic matter. Wish to send a signal faster than light. Pay with causality itself. The universe keeps its balance sheet clean. In everyday language, the universe acts like a patient accountant. You can move money between accounts, energy, time, curvature, but you cannot erase the debt. Every miracle comes with a receipt. There is a softer kind of shortcut, less famous, but more real gravitational assists. We already use planets and stars as slingshots, stealing momentum from their orbits. A probe can gain speed by falling into a planet's gravity well and swinging out at a sharper angle. These tricks work within the rules. They hint that cleverness can coexist with obedience, but they also remind us that the best shortcuts are not free. They borrow from larger systems that do not notice the theft. The metaphor that fits this chapter is a doorframe that exists only if you pay with negative cash. You step up to it, certain you can afford the crossing, and realize the economy it belongs to is imaginary. The moment you reach for your wallet, the door dissolves. Some see that as a disappointment. Others see it as poetry. The fact that physics allows the dream but forbids the practice gives our curiosity a horizon rather than a wall. If wormholes and warp bubbles remain out of reach, their absence becomes a design constraint for meaning. We are forced to find depth in locality, not glory in escape. Why this matters is not only scientific but moral. Every fantasy of an easy exit carries an echo of impatience. We want to leave before finishing the story of where we are. The denial of shortcuts pushes us to mature, to refine our questions, to invest in endurance instead of miracles. The failure of wormholes is the success of stewardship. Still, it is hard not to imagine what might have been. If space could be folded like paper, we would be cosmic commuters, visiting clusters as easily as continents. Empires would span light years. Communication would be instant. The night sky would become a network of reachable lights rather than a field of witnesses. Yet such a universe might not be livable. Without separation, there is no incubation, no evolution, no difference. The gaps between galaxies create privacy for creativity. Isolation is what allows complexity to survive. Think of civilizations as seeds scattered in separate gardens. If shortcuts existed, one aggressive species could devour all the rest. The universe may prefer distributed safety to centralized conquest. The walls we curse might be the reason life endures. Some researchers propose that wormholes might exist naturally at microscopic scales, quantum fluctuations connecting points across minuscule distances. If so, they flicker in and out of existence faster than any signal could use them. They are whispers in the vacuum, small enough to decorate the structure of space-time but too fragile to exploit. They may even help explain certain quantum effects, stitching probability into continuity. A reminder that nature plays with its tools but rarely lends them. So we return to the image of the closed door. Each time we calculate a possible passage, it fades. Each time we imagine infinite power, it recoils. The door opens just long enough to teach humility. The lesson is not defeat, but context. We are creatures meant to explore what is reachable, not to tear at the edges of existence. In plain terms, shortcuts are lessons dressed as temptations. They exist to remind us that even impossible dreams can reveal structure. Every failed attempt refines our understanding of what can survive. To build a machine that respects these limits is to align with the grain of the universe rather than cut across it. Why it matters is that hope itself evolves. We began wanting to conquer space. Now we learn to inhabit it. The absence of cheap travel turns exploration into patience, innovation into philosophy. The longer we remain confined, the more our tools resemble the stars they imitate: steady, enduring, discipline. If the roads that fold space close the moment we approach, perhaps the next challenge lies not in geometry, but in communication. When distance mocks velocity, maybe coordination becomes the new frontier. The next chapter will ask whether a civilization can stay one civilization when its own messages travel slower than its memory. Every heartbeat on Earth is timed to the same rhythm of sunlight, rotation, and memory. We live in synchrony because the delays between us are small. Words leave a mouth and reach another in seconds. Instructions cross oceans in milliseconds. A species can feel unified because its signals arrive while meanings still overlap. But stretch the scale, and that synchrony dissolves. Distance is not just space. It is time disguised as separation. When a civilization expands faster than its ability to talk to itself, it begins to fracture not through conflict but through delay. The rhythm breaks, and identity follows. The first clue is mathematical. Light, our fastest messenger, takes just over 1 second to cross from Earth to the Moon. It takes more than 8 minutes to reach the Sun. To travel to the nearest star, Proxima Centauri, requires over 4 years. Every message sent that far is a postcard mailed to another generation. Imagine a civilization scattered not across planets, but across hundreds of light years. An instruction from the core could arrive centuries later to a colony that has already changed language, government, and purpose. The command becomes archaeology. Coordination decays into myth. At its core, communication defines culture. Without shared reference, memory diverges. When time delay stretches beyond the span of patience, unity becomes impossible. What this means is that the farther we spread, the more we will resemble a tree of worlds rather than a single organism. branches that share a root but grow apart until they cannot see each other. Simply put, time travel in one direction forward is built into distance. By the time a signal arrives, the sender's present is already the receiver's past. The deeper you move into space, the more the notion of now collapses. Relativity makes this literal simultaneity is not a universal fact, but a local convenience. To one observer, two events happen together. To another, they are separated by years. A civilization that spans light years will never share a single clock. Its calendars will be regional, its history braided but never aligned. Think of it like this. You try to conduct an orchestra stretched across a continent. The conductor raises the baton, but the musicians hear the cue after an echoing pause. Each plays in perfect rhythm locally, but the sound that reaches the others is always late. Over time, the orchestra stops being one performance. It becomes a field of overlapping solos, still music, but no longer one song. The second clue comes from the simplest experiment in modern physics, timing signals in satellites. Even at the scale of a planet, relativity already shifts clocks. Satellites orbiting Earth experience time slightly faster than clocks on the ground due to weaker gravity and their motion. The difference is only microseconds per day, but if uncorrected, GPS would drift by kilometers within hours. That is how delicate synchrony is, even in a single system. Now imagine multiplying that error by billions and stretching it over light years. Precision collapses, and with it, coordination. Why this matters begins at the human scale. Communication delay changes what politics, science, and empathy can mean. On Earth, disagreement can evolve through dialogue. Across light years, it calcifies into separate philosophies. A debate about one policy could last generations. Colonies that left together could drift into ideological strangers. History would branch faster than it could be recorded. At first, this seems tragic. But there is a second reading. Diversity might be the price of cosmic scale. The loss of synchronization creates a spectrum of civilizations, each a variation on the same theme. Evolution thrives on isolation. When time delays isolate minds, they invent new solutions, new mythologies. The unity we lose in communication might return as richness in creativity. Perhaps no single civilization can stay in sync, but the species as a whole gains depth through divergence. Still, the emotional cost remains. How does it feel to send a message you will never see answered? Voyager's faint signal takes 18 hours to reach us, and it still orbits within our solar neighborhood. A message from a star hundreds of light years away would be heard centuries later. That is not communication. It is memorialization. We would build transmitters not to converse, but to be remembered. In everyday language, distance turns conversation into archaeology. Each transmission becomes a fossil of intent, dug up by descendants who can no longer question the motives of their ancestors. Meaning becomes one way. Even sincerity fades in translation across time. The third clue appears in the mathematics of signal degradation. Information decays as it crosses space. Background radiation, interstellar noise, and scattering distort even powerful signals. To maintain clarity, a civilization must spend increasing energy to shout into the void. The cost rises faster than the distance squared. Eventually, the power required to speak equals or exceeds what the sender can generate. Silence becomes more economical than conversation. The universe teaches humility through the price of talking. Imagine, then, a network of worlds separated by light years, each maintaining contact through a schedule of transmissions. At first, they exchange data, then summaries, then myths. 1,000 years later, those exchanges become formal rituals, celebrated even when the messages themselves are meaningless. The act of sending replaces the act of hearing. Civilization transforms into ceremony, a rhythm of one-way greetings cast into the dark. The metaphor that belongs here is a choir spread across an ocean. Each singer hears only their own voice reflected from distant waves. They try to harmonize, but the echoes never align. The result is haunting, beautiful, and lonely. The song still exists, but no one hears it whole. Why it matters is that synchronization defines empathy. We understand others because we share time with them. Delay removes that overlap. What happens to ethics when the suffering of others is visible only in history books? What happens to responsibility when decisions outlive accountability? A delayed world is not cruel, but it is indifferent by necessity. Compassion must evolve from reaction to foresight. A civilization that cannot stay in sync must practice moral prediction, acting today for those who will not answer for centuries. At its core, the problem is not technology but geometry. The finite speed of light enforces separation. To outsmart it, we would need communication faster than causality allows, something that could violate the order of events. The same walls that protect reality from paradox also prevent us from staying in step. Causality is the price of coherence. Lose it, and the universe dissolves into contradictions. Some speculate about quantum entanglement as a loophole, imagining instant communication through paired particles. But entanglement is correlation, not message. Measuring one particle reveals information about its twin, but the result is random until compared through classical signals limited again by light speed. The trick remains elegant but useless for sending meaning. The universe gives us no free lunch, only fascinating receipts. Why it matters also lives in culture. Stories, art, and science rely on shared rhythm. If communication delay erases that rhythm, each world becomes a separate author, unaware of others writing parallel tales. The cosmic library fills with independent volumes, never cross-referenced, never reconciled. Future archaeologists might find them and wonder how one species produced so many beginnings without endings. In plain terms, civilization expands until conversation breaks. Growth itself creates loneliness. The first explorers of interstellar space may not find aliens. They may find versions of themselves delayed by centuries, talking back through memory and lag. They will realize that communication at such scales is not dialogue but devotion. Yet, there is dignity in this delay. To send a signal you will never hear returned is an act of faith. To receive a voice from centuries past is an act of gratitude. In this way, synchronization gives way to succession. Each generation becomes a link in a message chain stretching beyond comprehension. Civilization becomes not a simultaneous society, but a relay race of meaning. Why it matters finally touches philosophy. The inability to stay in sync forces us to redefine unity. Perhaps coherence is not simultaneous understanding, but continuity of purpose. If distant descendants inherit your goals even after losing your words, you have achieved a higher form of communication, not messages, but momentum. So the silence between worlds need not be emptiness. It can be rhythm too slow for us to hear, like the pulse of a glacier or the drift of continents. It is music on scales that outlast perception. A civilization that cannot synchronize can still align in direction, like scattered stars forming a single spiral arm. If the choir cannot keep one beat, it can still sing one song spread across millennia. And when the echoes finally fade, what remains will not be confusion but heritage, the record of minds that tried to speak across eternity. When the beat itself breaks, perhaps the next question is what happens to meaning in that silence. The next chapter will turn inward, listening to the great silence itself, and ask whether loneliness across one galaxy can still create wonder. The Milky Way should be noisy. Hundreds of billions of stars, thousands of worlds that could hold seas, forests, machines. Even if life arises on only a fraction of them, the sky ought to hum with the static of civilizations calling out to each other. Yet every telescope hears the same thing, a hiss, ancient and impersonal, the leftover glow of creation. Between those frequencies, there is nothing, no greetings, no warnings, no signatures of thought. This quiet has a name, the Great Silence. It is the loudest mystery in our galaxy. Our first clue lies in arithmetic. Even cautious estimates suggest that life should not be rare. If planets form naturally, and chemistry repeats its habits. Then a galaxy as old as ours should have produced civilizations millions of years before ours. They would have had time to spread, to signal, to leave fingerprints on the stars. But we see none. The contradiction between expectation and evidence is what makes the silence so deep. The equations insist on company. The instruments record solitude. At its core, this contradiction may reveal more about us than about the cosmos. We assume that others want to be noticed, that they broadcast or expand the way we might. But what if survival prefers secrecy? A civilization that learns the dangers of attention may choose to go dark, to hide in the cosmic forest. Or perhaps the distances between stars are not barriers of will, but of physics and patience. Even if they tried, their signals might have thinned to whispers, scattered by the same expansion that guards the edges of the universe. In everyday language, the galaxy may be full of voices we no longer have ears for. They speak in wavelengths we do not monitor, at tempos slower than our curiosity can wait for. Silence is not proof of absence, only of mismatch. But to a species that equates contact with reassurance, it feels like abandonment. The second clue is statistical. Stars live long lives, but civilizations might not. Entropy, conflict, or exhaustion can erase them faster than they can colonize. The galaxy's memory may be written in ruins, rings of debris that once were satellites, isotopic scars in planetary crusts, energy patterns mistaken for natural phenomena. Our telescopes might already have glimpsed their relics without realizing it. The silence could be a graveyard speaking softly in spectra we misread. The third clue hides in the biology of survival. Life evolves under pressure to adapt, not to advertise. Communication costs energy and risk. On Earth, even intelligent species avoid announcing themselves beyond their needs. Most are quiet hunters or quiet prey, perhaps intelligence, on cosmic scales, matures into discretion. The first ones who shouted may have drawn attention they could not endure. Think of it like this. The galaxy is a dark ocean, and each civilization is a small ship with a lantern. At first, lighting that lantern feels noble, proof of existence. Then you realize there may be predators in the water. You douse the flame, lower your voice, and listen instead. If everyone does the same, the ocean looks empty, though it is crowded with eyes. Why it matters is not paranoia. It is humility. The silence could be an ecological signal, the universe selecting for quiet endurance over loud expansion. A civilization that consumes too fast or grows without limit burns out, leaving only ashes. Those that survive learn to balance ambition with restraint. If that is true, the great silence is not a void, but a lesson in moderation written across 10 billion years. Our fourth clue comes from energy. The tools of detection we use: radio waves, infrared surveys. Searches for waste heat are biased toward civilizations that act like ours. We expect big signals, bright cities, industrial noise. But advanced societies might run on principles invisible to us, directing energy so efficiently that they leave no trace. To us, efficiency would look like emptiness. The absence of noise could be the presence of mastery. At its core, the great silence may simply mean the galaxy has grown wise. We might be the adolescents shouting into the night, mistaking the quiet of adults for emptiness. In that case, our own signals, decades of radio, television, radar are the cosmic equivalent of fireworks brief. Beautiful, then gone. Perhaps the rest are waiting for the sparks to fade before speaking again. In plain terms, the galaxy may already be full of civilization, each one wrapped in its own cocoon of caution. They listen more than they speak. The distances between them are not only physical, they are psychological, born from the fear that the first to be found might also be the first to vanish. The metaphor for this chapter is a museum with its lights on, but no visitors. The exhibits are pristine. The air is still. and the hum of climate control fills the hall. Somewhere, a guard walks his route, unseen but not alone. The museum is civilization itself, self-sustaining, self-aware, and utterly quiet. It does not need applause to confirm its existence. The fifth clue is cosmic timing. We may have arrived early or late in the sequence of life. If consciousness blooms only in the later epochs of a galaxy's evolution, then we could be among the first to hear the quiet before the chorus begins. Or, conversely, we could be emerging after the music ended. Stars burn and die. Metal accumulates. Radiation ebbs. And perhaps the long phase of vibrant life has already passed. The great silence may be the sound of a party long over, its participants gone home, its echoes fading. Why this matters is emotional as much as scientific. Loneliness on a cosmic scale tests meaning. If we are alone, every story we tell becomes the galaxy's story. If we are not, then we are surrounded by listeners who choose not to answer. Both possibilities demand responsibility. The first asks for creation, the second, for respect. Another possibility, less comforting but honest, is that communication itself decays faster than civilization. Languages diverge, symbols drift, signals lose context. Even if two societies exchange data, translation might fail across centuries. The silence could be full of unreadable messages, like inscriptions weathered into stone, meaning perishes before the medium. Every civilization must learn to send not just information, but comprehension. To put it another way, the great silence may be what conversation sounds like when conducted across eons. We listen to the universe as if expecting speech, but perhaps the answers are written in the patterns of stars, in the regularity of laws, in the very fact that order persists long enough for minds to arise. Maybe the cosmos has already spoken, and the message is continuity. Why it matters deepens here. Silence shapes identity. A galaxy without replies forces introspection. We become curators of our own meaning. Instead of asking who else is out there, we begin to ask what kind of voice we want to leave behind. The act of searching becomes a moral exercise, a way of defining how we treat mystery. There is also comfort in knowing that quietness itself can be profound. If the galaxy were filled with shouting empires, the night would not be beautiful. The black between stars would lose its depth. The stillness that frightens us might be the condition that allows reflection, growth, and peace. The silence could be a lullaby, not a warning. Simply put, the great silence inside one galaxy teaches us to listen better. It asks for patience, for interpretation beyond noise. It invites us to think of existence as dialogue between order and void. In that dialogue, every act of science, art, or kindness is a word added to a conversation that might never end, but also never needs to. Why it matters, finally, is that searching itself unites us. Even if we never hear an answer, the attempt becomes our anthem. It connects generations under a single shared act of curiosity. In that sense, the search for others becomes the search for ourselves. So we continue to build dishes that listen and telescopes that stare into the ancient dark. Each one becomes an ear pressed against the void, hoping to catch the faintest whisper of kinship. If we hear nothing, the act still defines us. If we one day hear something, it will not erase the value of our waiting. Silence is not the enemy of wonder. It is its stage. When the hush of one galaxy teaches us patience, the next question begins to form like a shadow behind it. If this quiet is permanent, how do we preserve what we have before the fog of expansion erases even our own horizon? There is a cruel illusion hidden in the sky. The farther we look, the more of the universe we think we see. Yet every new measurement tells us that what we can reach is less than what we once imagined. The horizon does not stand still. It recedes. It is like watching the sea at sunset and realizing the tide is rising, not falling, that the line between light and darkness moves toward you no matter how far you walk. The future, For our species and every galaxy is one of shrinking horizons. The first clue comes from cosmology's most patient data. Light from ancient galaxies arrives stretched by expansion. The longer the journey, the redder the light. When we measure how red the most distant galaxies appear, we find that the universe's expansion is not slowing as gravity once was expected to do. It is accelerating. This acceleration means that the distance between galaxies increases faster and faster, carried by a pressure we call dark energy. It is invisible, measurable only by its effects, and it makes space itself grow. Simply put, the universe is running away from itself. Every second, galaxies beyond a certain distance cross a line where their recession speed exceeds light. It is not that they move through space faster than light, they move with it, but that the very fabric stretches too quickly for light ever to bridge the gap again. Each moment, more of the universe slips beyond reach. What we see today is already history from places that have left our causal neighborhood forever. Think of it like this: you stand on a shore watching ships sail toward the horizon. They do not sink because of curvature, but because the sea beneath them lengthens. Every second, the horizon moves farther away, faster than any ship could sail. The last you see of them is the echo of light that began its journey long before their true distance became infinite. The second clue lies in the cosmic event horizon, a limit defined not by sight but by time. There is a maximum distance from which light, sent now, will ever reach us in the future. It's roughly 16 billion light-years today. Beyond that, no signal can ever arrive. No matter how long we wait, this line is not fixed. It shifts slightly as the expansion rate changes, but its meaning remains the same. There are places in the universe that will never again share information with us. The visible universe. What we can see is larger than the reachable universe, what we can influence. The difference widens every second. At its core, this means that our cosmic neighborhood is shrinking in a way that perception cannot detect. The night sky still looks rich, crowded with billions of suns. Yet most of those stars belong to galaxies already departing beyond recall. Their light is a postcard mailed billions of years ago, and we are reading it at the moment before the post office closes forever. Why it matters reaches beyond astronomy. This horizon defines the limit of future history. Eventually, all galaxies beyond our local group will vanish from view. Their light will redshift until it fades below detectability. Even with perfect telescopes, future astronomers will see only a static island of stars, the Milky Way merged with Andromeda and a few dwarfs. The cosmic web will become a local pond. Those who live then will not know the universe was ever larger unless they inherit our records. The cosmos will appear finite, calm, and lonely a lie told by time. In everyday language, the universe is erasing its own footprints as it walks forward. The trail behind it glows for a while, then fades. Our telescopes catch the footprints just before they dissolve, and our duty is to preserve them before the light slips away. The third clue lies in the relic light that surrounds us, the cosmic microwave background. It is the oldest message we can receive, the faint afterglow of the universe's birth. As space expands, that light cools, its wavelength stretching like the memory of a word whispered too long ago. In another 100 billion years, even that whisper will fade below detection. The record of origins will vanish. Physics itself will seem incomplete, not because the laws have changed, but because the evidence has gone dark. The metaphor that fits this chapter is a window that fogs as you look. At first, you can see the landscape beyond the forests, the river, the mountains. Then condensation forms, softening the outlines, muting the colors, until all that remains is your own reflection. The universe's future observers will live in that reflection, surrounded by evidence of themselves but blind to what came before. The window never shatters, it simply becomes opaque. The fourth clue is that this shrinking is irreversible. The acceleration of expansion is not a temporary burst, but a steady feature of dark energy. Unless dark energy itself changes nature, the horizon will keep drawing inward relative to what we can see. The galaxies within our gravitationally bound neighborhood will remain companions, Everything else will vanish into unobservable exile. The grand stage of the cosmos will contract until only our small troop remains under the spotlight. At its core, this is not doom, but perspective. The universe was never promised to remain visible. It evolves by hiding itself. We, by contrast, evolve by remembering. The more we learn about this vanishing, the more urgent memory becomes. Our data, our maps, our records are time capsules for minds that may never know how big the sky once was. Why this matters is that the shrinking horizon redefines what exploration means. The final frontier is not out there, it is documentation itself. The task of cosmology becomes archiving the reachable universe before it dissolves. Each new observation is a photograph of a disappearing landscape. To study cosmology is to practice rescue work at the edge of forever. Simply put, we live at the only moment in cosmic history when the whole picture is visible. Too early, and galaxies had not yet formed. Too late, and they will have faded away. We are at the midpoint of revelation. The brief window, when the curtain is open. The light that reaches us now carries information we can never replace once it passes. The act of looking is itself preservation. The fifth clue is that our instruments already catch this retreat in progress. When we map galaxies by distance, we find that some appear to move away faster than light. Though relativity remains safe, space stretches between us, carrying them outward. In the far future, even those galaxies' remnants will be stretched so thin that their radiation will be undetectable. Time will turn visibility into a privilege of proximity. Why it matters becomes existential. Knowledge has a half-life. If the cosmos deletes its evidence faster than minds can arise to study it, then meaning itself becomes perishable. The only antidote is to build archives that endure longer than stars, to build memory machines not to defy entropy, but to negotiate with it. Think of future astronomers looking up from a merged Milky Way and Andromeda. They will see only a few local galaxies and the black beyond. Their physics will suggest a static universe, infinite and unchanging. The expansion we measure today will be invisible to them. Unless we leave messages data encoded in long-lived systems, they will rediscover the cosmos from scratch, never knowing what was lost. In plain terms, our generation lives in the age of evidence. We can still trace the fingerprints of origin, still watch the retreat of galaxies. It is our duty to become historians of light, to pass on the story of what we see before the record evaporates. The shrinking horizon does not diminish us. It defines our role, why it matters one last time. This realization turns the cosmic scale back into human urgency. Against the backdrop of an expanding void, our libraries, satellites, and memories become sacred instruments. To record is to resist disappearance. Each observation adds another stone to a monument that might one day be the only proof that the universe was once connected. The horizon will continue to move. The fog will thicken. But for now, we can still see the edge, still measure the distance, still speak to the light that left billions of years ago. The future will live inside a smaller sky, but our voices, if recorded, if remembered, can give them back the stars. If the horizon fades and the distant view disappears, the next act will turn inward, asking what kind of meaning survives when the universe stops expanding for us and starts echoing inside our minds. In the beginning, we looked outward because the darkness seemed infinite. Every new discovery promised more of everything: more stars, more time, more chances to escape the fragility of being mortal. But after the long chase through engines, distances, and limits, the same gaze turns back upon itself. The universe is not a ladder to climb, but a mirror that deepens the longer we stare. What we once called expansion was never only about space, it was about curiosity, the force that stretches minds just as gravity stretches light. Now, at the far end of knowing, we meet the reflection of that curiosity and call it meaning. The story we have followed of walls, speed limits, deserts, entropy, And silence was never about impossibility. It was about precision. The cosmos is not unkind. It is exact. It lets no one cheat. Yet it rewards those who learn the shape of the cage. Every wall has taught us proportion. Every unreachable horizon has framed a question that could still be answered from within. A prison with infinite room for understanding is not a prison at all. Imagine standing in the heart of the Milky Way, long after the last external galaxies have disappeared. The sky is still jeweled with local stars, bright and near. But the cosmic ocean beyond has fallen silent. No trace of other clusters. No glow of expansion. A younger species might mourn the loss of the wider view, but an older one, tempered by patience, would see a different kind of inheritance. The shrinking horizon turns into a dome of responsibility. The last lights that remain are the ones we must tend. In plain terms, when the universe stops giving us more to discover, the task changes from exploration to preservation. Meaning migrates from the frontier to the hearth. We become archivists of existence, caretakers of a library written in gravity and chemistry. The purpose of knowledge becomes continuity. The first truth that settles here is this: limits are the foundation of value. A universe without boundaries would offer no reason to choose, no reason to care. We measure worth by rarity, and finitude is the rarest condition of all. Every galaxy that vanishes behind a horizon becomes a reminder that time itself is the only resource we cannot recycle. The end of reach gives weight to what is reachable. The second truth is that intelligence has always been an act of translation. Stars convert matter into light. Minds convert experience into understanding. When one process ends, the other must continue its work in a different form. The energy that once powered telescopes and rockets might one day power vaults of memory and vaults of life, buried deep within planetary crusts or orbiting eternal suns. The shift from movement to memory is not defeat. It is adaptation. Think of it like this: when a fire burns low, we move closer to its glow. The shadows lengthen, but the warmth becomes sharper. So it will be with us. The darkness will not devour us. It will define the outline of what remains. A civilization that understands its horizons are shrinking learns a final discipline: the art of significance. To make something meaningful is to shape time deliberately. Every archive we build, every story we preserve, is a structure that slows decay. Perhaps the greatest technology will not be propulsion or communication, but endurance, the ability to keep a thought alive long enough to become part of the universe's memory before it forgets itself. At its core, this is not a story of loss. It is the slow revelation that the universe's indifference is the canvas upon which we paint compassion. If no one answers our signals, then kindness becomes the proof that consciousness matters. We do not need witnesses, we need purpose. The great silence inside one galaxy does not erase meaning. It multiplies the responsibility of every thinking being to create it. Why it matters is that the boundary between knowledge and wonder has dissolved. Once, we treated mystery as a gap to fill. Now we can see it as the field that nourishes understanding. When the outer horizon fades, an inner horizon takes its place, the expanding reach of empathy, reflection, and legacy. The cosmos, once external, becomes internal. The stars move inside the mind. The philosopher's fear was that discovery would end. The scientist's fear was that meaning would vanish with it. But meaning is not a property of discovery. It is the act of caring about what is discovered. That act can survive any physics, even in a cold universe. Concern is a kind of warmth. It is the fire that entropy cannot count, because it exists in intention, not temperature. Simply put, the cosmos is not empty. It is full of potential memory. The task now is to decide what to remember, and how. A civilization that accepts isolation as permanent might respond not by despairing, but by perfecting its own story. It might refine its ethics, deepen its art, slow its heartbeat until centuries feel like seconds. Such a culture would not fight entropy. it would repurpose it, using decay itself as the measure of endurance. To endure is to resist noise long enough to pass the pattern forward. We can imagine that somewhere, billions of years from now, beings or machines built by our descendants will still orbit a quiet star. Around them, the sky will be almost black. Yet in their archives, the light of vanished galaxies will still burn photons stored in data, maps of constellations that no longer exist. They will read our observations as scripture, not because we were wise, but because we saw when the universe was still wide. To them, our era will be the mythic dawn when everything was visible and curiosity could still reach beyond the horizon. They will not envy us. They will inherit our question. Why it matters becomes clear in that image. To live at the midpoint of time, to witness both the expanse and the contraction, is a privilege of awareness. The universe is not closing against us. It is teaching us scale, and scale teaches grace. We learn that even a civilization lasting a few million years is not a failure against eternity. It is a brief, magnificent flash that proves complexity was possible. The metaphor that holds the final thought is simple, a candle burning in an endless cathedral. The darkness around it is not a threat, but a frame. The light defines itself by contrast, and the flame is steady precisely because the air is still. The candle will go out, yes, but the warmth it gives will linger in the memory of the stone. That is what existence can be: brief, bright, sufficient. At the end of this long reflection, one truth remains unbroken. The cosmos does not owe us meaning. We give it meaning by paying attention. Each observation, each act of care, each work of understanding is a declaration that awareness itself is valuable. That declaration is the last light we carry. And so, when all horizons have drawn inward, when galaxies fade and memory slows, a single question will remain for whatever minds endure if the universe forgets itself. Will it remember that for a time? We remembered it.